Hello everyone. In this video we are going to be considering the general equation of a circle. In the previous video we considered the standard equation of a circle. If you haven't seen the video, just click on the link at the top right hand corner of your screen. Now here is a circle, center C, and this line that runs from the center to the circumference is called the radius. Now in the previous video I represented the center with C and a point on the circle with T. Of course, the coordinates x comma y. Center is h comma k. Then the standard equation of this circle was found to be x minus h all squared plus y minus k all squared is equal to r squared. This is the standard equation of a circle centered at h comma k. Now we would see that this equation here can be used to obtain the general equation of the circle. First, let's remove the brackets. Now, if I remove the brackets x minus h all squared, I would have x squared minus 2hx plus h squared. Now, if I do the same for y minus k all squared, I would have y squared minus 2ky plus k squared. And of course, the right hand side is r squared. Next is, I want to make all of these to be equal to 0. So that would give x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared minus r squared equal to 0. Now I want to do a little bit of rearranging here. So this equation can be written as x squared then plus y squared. So I have minus 2hx minus 2ky then plus h squared plus k squared minus r squared equal to 0. I've only reordered the items here. Now, I can see that there are a number of constants in this equation. H is a constant, the x coordinates of the center. K is another constant, the y coordinate of the center of the circle. Of course, since h and k are constants, definitely h squared, k squared would also be constant. And we know that the radius is a number, it's also a constant. So these are the constants in this equation. So what I want to do is, I want to let the first constant, but I'm going to pick the negative here with it. I want to let negative h to be equal to g. The second one, I'm going to pick the negative with it. Negative k, I want it to be equal to positive f. And the final part, h squared plus k squared minus r squared, I want it to be equal to c. Then this equation is going to transform to x squared plus y squared plus 2gx, because the negative h is plus g, so this becomes 2x times g, that's 2gx. Similarly, negative 2ky would become plus 2fy. Now, h squared plus k squared minus r squared is c, so I'm going to have plus c equal to 0. This is the general equation of the circle. One quick thing about the general equation of the circle. Of course, since this is the standard equation of the circle, we know that the center here is h comma k. But for the general equation of the circle, the center is at negative g comma negative f. And we know what the radius is. The radius is the square root of g squared plus f squared minus c. So for the general equation of a circle, the center is at negative g comma negative f, and the radius is the square root of g squared plus f squared minus c. Also, we would see that this equation does not have any xy term. There is no product xy. Also, we can see that the coefficient of x squared and y squared is the same. So these are the features you would see that would make you recognize that the equation is an equation of a circle. First, the coefficient of x squared and y squared will be the same. Second, there's not going to be the product of xy. There's not going to be a term having xy. So those two things are very crucial in the general equation of a circle. Next is to solve a number of problems. Here is the first example. Obtain the coordinate of the center and radius of the circle, x squared plus y squared minus 6x minus 8y plus 21 equal to 0. Solution. The first thing we are going to do here is to compare this equation with the general equation of the circle. And we know that the general equation of the circle is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. That comparison would allow us to see that the blue equation is in actual fact an equation of a circle, because we can see that the coefficient of x squared and y squared are the same. That's the first condition. The second condition is that there shouldn't be any xy term. So as we can see here, there is no term here that involves the product of x and y. Okay, so comparing both equations, we would see that negative 6 is going to be equal to 2g. Also, negative 8 is going to be equal to 2f, and c is going to be equal to 21. So we have 2g, that's the coefficient of x in the general equation, being equal to negative 6, because negative 6 is the coefficient of x in the equation that we are given. Solving this, we would have g is equal to negative 6 over 2, and this is negative 3. Similarly, 2f, which is the coefficient of y in the general equation, is going to be equal to the coefficient of y in the equation that we are given, that's negative 8. Dividing both sides by 2, f is going to be negative 8 over 2, and this is negative 4. And as we found, c is positive 21. Okay, so this is going to allow us to obtain our center. So we have to recall that in the general equation of a circle, the center is not g comma f, it's negative g comma negative f. So since g is negative 3, negative g is going to be negative negative 3. Since f is a negative 4, negative f is going to be negative negative 4. So the center here is going to be negative negative is positive. So that's going to be 3 comma 4. Okay, so the next thing is going to be to obtain the value of the radius. The radius is g squared plus f squared minus c. This is the radius of a circle. Of course, the general equation of the circle. So since g is negative 3, so we are going to have negative 3 squared. F is a negative 4, that's negative 4 squared. Then minus, c is 21, so this is going to be minus 21. Negative 3 all squared is 9. Negative 4 squared is 16. Minus 21. 9 plus 16 is 25. Minus 21 is 4. So this is 4. Therefore, the radius is going to be equal to 2. So we can conclude that the center, negative g comma negative f of this circle, whose equation is in blue, is equal to 3 comma 4, and its radius is equal to 2. Example 2. What is the coordinate of the center of the circle, whose equation is 5x squared plus 5y squared plus 2x minus 1 equal to 0? State the value of the radius. Solution. So the first thing we are going to do is to state the general equation of the circle, x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Now, we should not forget that the general equation has center of negative g, comma, negative f, and a radius of the square root of g squared plus f squared minus c. Okay, so the red equation, that's 5x squared plus 5y squared plus 2x minus 1 equal to 0. Now, if we compare both, we would see that first, the coefficient of x squared and y squared are the same. So that's good, because if the coefficients are different, then this equation would not be representing a circle. But we need to make the coefficient 1, the coefficient of x squared and y squared. So the first task ahead of us here is going to be to divide both sides of the red equation by 5. Now, doing that, we would have 5x squared over 5 plus 5y squared over 5 plus 2x over 5 minus 1 over 5 equal to 0 over 5, because we are dividing both sides by 5. Thus, 5 is going to clear 5. It does the same thing here. So I'm going to have x squared plus y squared plus 2/5 minus 1/5 equal to 0. So the next thing is going to be to compare, and we would see that the coefficient of x in the general equation is plus 2g, and the coefficient of x in the new equation is 2 over 5. So 2g is going to be equal to 2 over 5. Similarly, in the general equation, the coefficient of y is 2f. Here we can see that there is no term for y. So that can just be, we can assume that this is plus 0y. We can make that assumption. So this is what I'm saying. I'm going to write it clearly here. This equation in blue can be written as x squared plus y squared plus 2 over 5x plus 0y, because 0 times y is 0, so it's still the same, minus 1 over 5 equal to 0. So this is going to help us extract our 2f. So we can see that here in the general equation, the coefficient of y is plus 2f, here is plus 0, which is just 0. So 2f is equal to 0. Now next is c. So the constants, and this is negative 1 over 5. So I'm going to have c equals negative 1 over 5. Now solving this, if 2g equals 2 over 5, to obtain g, I'm going to have to divide both sides by 2. So if I divide the left by 2, I'm going to be left with g. Dividing the right by 2, so this is it. So this is 2 over 5 times, this is going to change to a multiplication, and I'm going to flip the item on the right. So this is 2 over 1, it becomes 1/2. 2 is going to make way for 2, so my g is 1 over 5. So here 2f is equal to 0, f is going to be 0 over 2, and that is 0. So I have my three parameters. G is equal to 1 over 5, f is equal to 0, and c equals negative 1 over 5. But the center is not g comma f. The center of the circle is negative g comma negative f. So if g is 1 over 5, negative g is going to be negative 1 over 5. If f is 0, of course, 0 is neither positive nor negative, so this is just going to be 0. So the radius is the square root of g squared plus f squared minus c. So substituting those values, g is 1 over 5, that's 1 over 5 all squared. F is 0, that's 0 squared, minus, so c is negative 1/5, so I'm going to have this and enclosed. Okay, so 1 over 5 all squared from indices, this is going to be 1 squared over 5 squared, that's 1 over 25. 0 squared is just 0. So negative negative is positive, so this is 1 over 5. So this is just 1 over 25 plus 1 over 5, but I can just write this as 5 over 25 from equivalent fractions to make it easy. So since the denominators are the same, I'm just going to add up the numerator. So 1 plus 5 is 6, so this gives 6 over 25. Now from the rules of surds, the root of a quotient is the quotient of the individual surds. So here I can split the square roots, so this is going to be root 6 over root 25. 6 cannot be simplified beyond this, so this is just going to be root 6, but root 25 is 5. So this is R. Therefore, in conclusion, the center of the circle is negative 1 over 5, 0, and its radius is 1 over 5 square root of 6. So you can try out these problems on your own. I hope you found this video useful. If you did, kindly like, subscribe, and share it. Thank you for watching. See you in the next video. Bye.